Welcome back to the video series of Opengyan. In the previous videos, the solid principle was discussed and it's a guideline which helps to design a class. But it's just a guideline. Ask a builder to build a house and each one has a different idea and a model even though the guidelines are same for all of them. Similarly, designing a class is also different for each scenario. It's a decision that every designer has to take. Let's just view some of the scenarios and the reasoning behind it in this video. What we see here is a nice little family, a dad, mom and siblings. If you are asked to write a class for this family, how will it be? How will you view it? A class with the following members, my dad, mom and children, or class with just people. Now the first option looks good for you with a human relationship perspective, and the second option doesn't feel right. But consider the scenario of IRCTC. Booking a ticket and the application doesn't care for mom or dad or children, it just says 4 people. On the other hand, a genealogy tree building software needs the first option. The first point is understand the need for the class before deciding the class itself. Fine. Now that the class members are set, the next dilemma is the part of who does what. For many of the college students, the course selection is a major activity to fill up the prerequisites and enrolling. Consider a college wherein the students are being offered courses. Now obviously there are 3 objects: the college class, course and the students. And as we can see, we have 2 options here. The use case is that of adding a student. College can get the courses from the student and give it to the courses class to check the eligibility. The second option is the college object can get the prerequisites from the courses and give it to the student object to check. Both are feasible. The first option can be argued saying that the courses class has the knowledge of the prerequisites and well placed to decide. The second option can be argued saying that the student's object has the details of the credentials and therefore it can map the prerequisites better. Hence both seem to be acceptable. But the problem is, whenever a new course is added, the logic has to be rewritten and all the complex course mappings, eligibilities have to be rewritten, and thereby reusability paradigm is broken. On the other hand, having the decision on the student class poses a problem for graduate versus postgraduate as well as different stream of students. Hence, the solution is to place the decision as a common interface outside the control of both the classes. The idea is to keep the data and the decision loosely coupled. So when adding a student, get the prerequisites from the course, get the courses from the student and then check it outside. Now my favorite. We talked of sambar. Now let's just talk about McDonald's Happy Meal. For those who are food lovers, they would have visited and tasted food in many restaurants. Full course meals, be it in the Residency or Saravana Bhavan, we all liked it. Now how about a class for the meals? Try says have the melon, the steak, the potato, pie, peas and corn all together in the meal class. It is easy to arrange, access, to deliver. Let's say for example I want a spicy corn, I can say meal.corn.taste equal to spicy, and then the price of it is just a summation of all the objects. It looks easy and simple. This method of designing classes is a shallow method. The other method is like this: a melon, a platter and a pie, wherein the platter has a steak and the trimmings of the steak. The trimming class in turn has the peas, the corn and the potato. This may look complicated. Let's say for example, again if I have to set the corn taste to be spicy, it has to be meal.platter.trimmings.corn.taste equal to spicy. It looks to be a roundabout way, but hey, if someone wants a steak platter in a different course, then it is easy to just move it and fit it with a soup, platter and ice cream instead of melon, platter and pie. So it operates on the principle of encapsulating and abstracting the containers as is the requirement. So next time when you eat the meal, think of it reusable courses in the 5-course meal. So how do we decide the members of a class to be an object versus an attribute? A rule of thumb is to go by answering the question, to have versus to contain. Let's read the sentences. An engine contains piston. An engine contains maximum horsepower. An engine has pistons. An engine has maximum horsepower. So the rule of thumb is, when the has sentence makes a sense, then it's an inner object and it has to be mapped as a class, and when the contain sentence makes sense, it is an attribute. So an engine contains maximum horsepower, an engine has pistons. To summarize, before getting to write a class, know the scenario, decide the level of abstraction, encapsulate the attributes, and decide on the interfaces, and then, only then, go about designing. After all, practice makes it perfect. Have a nice week ahead and decide well on your choice of class creation. See you next time. Join us in Facebook and write to us.